USGS, Science for a Changing World. We'll give the land. When a member of the Sioux Falls business community blurted out that promise in Washington, D.C. in early 1970, it tipped the scales in the city's favor. Sioux Falls, South Dakota, would be the future home of the USGS Earth Resources Observation and Science Center. Who could have anticipated that 50 years, 9 satellites, and thousands of employees later, the EROS Center would host one of the largest image archives in the world, with a staggering 74 petabytes of data? Or that the Landsat satellite program and EROS research would have an annual economic impact of over $3 billion worldwide. In the post-Sputnik mad dash to explore space in the 1960s, NASA was focused on the moon. But the USGS saw equal promise in the early Earth images taken by the U.S. astronauts. Scientists William Fisher and Charles Robinoff pitched the idea of a fixed-orbit satellite trained on the Earth's landscapes, collecting consistent images of the entire planet to observe change. USGS Director William Pecora sold the idea to Secretary of the Interior Stuart Udall, who essentially created the EROS program via press release in 1966. In 1968, NASA agreed to build the Earth Resources Technology satellite, ERTS-1. Once the Department of the Interior determined the center of the lower 48 states would be the best place for satellite reception, cities from Topeka, Kansas to Sioux Falls started competing to host a space-age, high-tech data center to develop, catalog, and interpret what was estimated to be 25,000 images in the first year. South Dakota had an edge with its high-powered congressional delegation. Senate Minority Leader Carl Mundt, a personal friend of then-President Richard Nixon, and Representative Ben Rifle, both were the ranking members of the respective Interior Appropriation Committees. They worked to secure funding for the project and tipped off Sioux Falls Development Foundation members about the possibilities. On March 30th, 1970, another preemptive press release, this one from Mundt's office, proclaimed that Sioux Falls had been chosen, somewhat before it was 100% official. Now the hard work of making the center a reality began. By the end of July 1970, $480,000 had been gathered from various community fundraisers to buy the land for EROS, and now it was time to find a site for the data center. The Sioux Falls Development Foundation bought 318 acres of land from the Froseth and Heggie farms. Federal funding to build the center stalled in Washington, D.C., so an innovative solution was devised. The Development Foundation would secure the $5.5 million loan, build the center, then lease it back to the federal government for 20 years until it was paid off. There was no template for how to build a photo processing and interpretation facility on this scale. Sioux Falls architectural and engineering firms designed the building and infrastructure, including 5 processing pools to ensure that photochemicals didn't enter the groundwater system. The new building would not be ready in time to begin processing Landsat-1 photos, so the Sue Hudson building in Sioux Falls became the downtown office. With a lot invested, the Development Foundation staged the groundbreaking ceremony with characteristic panache. Pecora, Barron, and Landis helped guide a mule-drawn plow at the EROS site on a cool morning in April of 1972. During the ceremonies, Fisher, one of the scientists who conceived of EROS, summed up the massive scale of the project. It is the largest Earth scientific experiment ever undertaken by man, and possibly the most significant. Landsat-1 launched on July 23, 1972. A delegation from South Dakota in attendance included Governor Dick Knipe and many of the Sioux Falls Development Foundation supporters who had worked to make EROS a reality. The first light images of Dallas, Texas on July 25th caused a stir at EROS. The negatives were barely usable. Eventually, the EROS team blasted enough light through them to produce usable photos, and the process was adjusted for the subsequent discoveries, which came pouring in. Shortly after launch, an 81,000-acre fire was revealed in isolated central Alaska. Galloping glaciers were observed on Denali on January 11, 1973. Volcanoes and glaciers in Iceland were seen on January 23rd. And on May 15th, the press release noted what might be the first ever remote sensing and land change observation, a comparison of the Mississippi River from October 1972 with the same area flooded in March 1973. Every 18 days, Landsat 1 recorded a complete scan of the entire Earth. And that ability to consistently detect land change over time across the globe was unprecedented in human history. Scientists immediately saw the possibilities for mapping, agriculture, disaster relief, locating minerals, forestry, and dozens of other applications. Even before the EROS Center opened its doors, 33 researchers from around the world came to Sioux Falls for the first international training course in June 1973, learning how to read satellite imagery. On August 7, 1973, 2,000 people attended the opening of the EROS Center. There was so much interest in the new site that a second event was held August 12th, this time pulling in 5,000 visitors. Along with international visitors, officials and scientists from state and federal agencies flocked to EROS in those early years, all hungry for training and data. In September 1973, a new director was named Alan Watkins, formerly the deputy program manager for NASA's Earth Resource Program. This allowed Glenn Landis to focus on the data production and distribution. There were now 124 employees, but more were needed. So in the face of a federal hiring freeze, Technicolor was named as the first contractor at EROS to oversee the on-site technical support staff. At the beginning of 1974, the new facility went fully operational, and by the end of the year, EROS employed almost 300 people, with a payroll of $2.5 million. 12,000 Landsat satellite images were added every month, and the total number of images in the archives, including aerial imagery, was close to 6 million. In January of 1975, NASA renamed the ERTS program to Landsat. The announcement coincided with the launch of Landsat 2 on January 22nd. As NASA and EROS finalized an agreement in 1975 ensuring that EROS would continue to distribute data, the center was flourishing. On January 5, 1976, the Burroughs 6700 mainframe computer was installed, making EROS home to one of the biggest computer systems in the Midwest. March 5, 1978, Landsat 3 launched. 1979 brought a key improvement. The DOMSAT antenna was installed to receive Landsat MSS data directly from Goddard Space Flight Center. It became operational in May after testing, ending the era of receiving film and computer tape via mail or commercial aircraft, greatly improving data processing time. Mount St. Helens erupted May 18, 1980. When the ash settled, Landsat captured the aftermath, and the archive at the USGS Earth Resources Observation and Science Center proved its value once again, with vivid before and after images showing the extent of the devastation. Despite the clear benefits of the EROS archive at the time, the future of the center and the program in the 1980s were not guaranteed. In November 1979, President Carter had issued a directive transferring Landsat operations from NASA to the National Oceanic and Atmospheric Administration. The directive recommended that the operations of satellite and data distribution be passed to the private sector over a 10-year period, and that the archive itself might be moved. Both possibilities concerned EROS employees and supporters. At the time, EROS and the Landsat program were expanding in many directions. In 1980, a solar energy water system was installed. It was one of the largest in the United States at the time. By 1982, there were 11 Landsat data distribution centers around the globe and more than a dozen Landsat ground stations receiving satellite imagery. Research and science topics thrived. agricultural inventories, archaeology interpretation, urban and regional planning, and wildlife habitat studies. In 1982, Landsat 4 was launched, the first satellite in the program to provide natural color images thanks to the thematic mapper and its additional spectral bands. Even with all this activity and innovation, bumpy roads lay ahead for EROS. In June 1984, Congress passed the Land Remote Sensing Commercialization Act, making the commercialization of Landsat data official. Two companies emerged in the competitive process to run the program. Kodak dropped out from the running, leaving EOSat to be awarded the contract on September 27, 1985. Landsat 5 was launched on March 1, 1984. The long-lived satellite captured some of the most famous Landsat scenes. One historic time series came in 1986 after a reactor meltdown in Chernobyl, which led to concerns that the USSR was understating the extent of the disaster. In May, EROS director Al Watkins was interviewed by Dan Rather on CBS Evening News, explaining how scientists use Landsat imagery to assess the damage. The commercial EOSat contract included the operations of Landsats 4 and 5 and a mandate to build 2 new satellites. In 1988, NOAA and the USGS agreed to keep the archive at EROS, although no funding was designated for its maintenance. While recognized worldwide for their benefits, NOAA gave the order in 1989 to shut down Landsats 4 and 5. In response, 100 members of Congress sent Vice President Dan Quayle, the chair of the newly created National Space Council, a letter seeking to preserve the program. Quayle helped secure funding for the remainder of the fiscal year. In June, thanks to a unanimous recommendation from the Space Council to provide an additional $24 million, the Bush administration announced a civil remote sensing program would be retained. Through all these storms, EROS maintained its watchful eye on land change, including monitoring the Yellowstone National Park fires in 1988 and supporting cleanup efforts of the Exxon Valdez oil spill in Prince William Sound in 1989. In a 1990 NASA flag-raising ceremony at EROS, the USGS and NASA announced that EROS would host the Land Processes Distribution Active Archive Center, LPDAC. In 1992, the Land Remote Sensing Policy Act, introduced by South Dakota Senator Larry Pressler, would not only repeal the commercialization of Landsat, but also extend the life of the program beyond 2000 and designate EROS as the National Satellite Land Remote Sensing Data Archive. Landsat 6, the only commercial Landsat launch, failed to achieve orbit in 1993, further punctuating the decision to end commercialization. In the midst of big announcements, EROS saw plenty of other activity. EROS began producing bi-weekly greenness maps of the conterminous United States based on composite AVHRR data in 1990. And in 1992, a new system began converting Landsat MSS data from high-density tapes to smaller digital tapes, saving images on the verge of permanent degradation. May 31, 1994, groundbreaking was held for a $9 million, 65,000-foot addition to the southeast of the original building. It would be necessary to help house Landsat 7 efforts and the LPDAC. Events in 1996 to mark the opening of the addition included an open house that brought more than 4,000 visitors on a tour of the new space. In 1995, the LPDAC data distribution system was completed with the ability to hold 2.4 terabytes. In 1996, EROS Archive benefited from the addition of reconnaissance satellite imagery, more than 900,000 scenes following the announcement of the declassification of the imagery. Other science and technology highlights included producing the first global AVHRR greenness map in 1993 and earning a Federal Leadership Award for it, and then in 1994 producing 10-day global AVHRR datasets. In 1994, EROS debuted Internet access to data products for the first time, allowing customers to directly download data to their computers. By September of 1994, more than 70,000 datasets were being downloaded each month. In 1996, transcription of all Landsat, MSS, and thematic mapper data at EROS to digital tapes was completed. In 1997, EROS finally received an antenna dedicated to Landsat satellites. Unfortunately, a little over a month later, a storm struck EROS with hail the size of softballs, cratering the antenna beyond use. The hail also cracked atrium roof panels, demolished the solar panel system, and ruined vehicles. Damage totaled more than $1 million. When the antenna was reconstructed, EROS was ready to downlink data after Landsat 7's launch on April 15, 1999. 3 days later, EROS processed the first signals from Landsat 7, including imagery of southeastern South Dakota. As a new millennium dawned, EROS looked forward to a future full of new data and new science. Data rolled into EROS from Landsat 7 and Terra satellites, which had both launched in 1999.
3, 2, 1, main engine start, and liftoff of the Atlas rocket with Terra, flagship of the Earth Observing System.
Data headed out of EROS as the data access website Earth Explorer became operational in March 2000 and has grown to contain the Landsat archive, aerial photography, declassified and additional satellite imagery, digital elevation model datasets, and drone and radar imagery. One scientific feat kicking off the 2000s was completion of the first national land cover dataset, NLCD 1992. Offering a 30-meter resolution based on Landsat 5 data. NLCD became the definitive USGS land cover product for the United States. Art also entered the EROS picture with the first Earth as Art exhibit based on colorful Landsat 7 imagery, debuted in November 2001 at the Washington Pavilion of Arts and Science in Sioux Falls, South Dakota. Events in the life of the Landsat program often affect EROS in a big way. In 2001, Landsat 4 retired. The same year, EROS began directly downlinking Landsat 5 data and received the Landsat 5 archive from the commercial operator. In 2003, the scan line corrector failed on Landsat 7's ETM Plus sensor, resulting in data gaps for each scene. EROS staff worked to find strategies to fill in missing data. However, with lower prices and demand for Landsat 7 data, the EROS workforce was affected. But the archive continued to add a considerable amount of Landsat 7 data. Then, in 2010, an effort began that would increase the size of the Landsat archive by more than 6 million images. Through the Landsat Global Archive Consolidation Project, EROS sought out reels and tapes from various Landsat ground stations around the world with many unique images to bring all Landsat data into the EROS archive. The Guinness Book of World Records recognized Landsat 5 as the longest operating Earth observation satellite after its 28 years and 10 months of service. Landsat 8 launched February 11, 2013, after much research and discussion about what the Landsat data continuity mission should include. Some EROS staff attended in person, others watched remotely from the auditorium. The newest satellite met the high hopes of scientists with the new operational land imager and thermal infrared sensor instruments. Landsat 9 launched with a similar design to Landsat 8 on September 27, 2021, and EROS hosted the transfer ceremony the following August. Landsat 7 remains in service when normally it would have shut down after the launch of Landsat 9. Landsat 7 currently orbits at a slightly lower altitude but still collects data in the Extended Science mission. Around 2026, NASA will attempt the first refueling of a live satellite by sending up a robotic spacecraft to refuel Landsat 7. EROS looks forward to the launch of the 10th Landsat satellite, Landsat Next, which will bring a new era of design and data to the program. In about 2030, the constellation of 3 smaller satellites is planned to begin orbiting with a closer look at Earth on a more frequent basis with more capability for collecting additional data. Beyond Landsat, EROS continues to add aerial and drone imagery, and the LP DAC at EROS has greatly increased its offerings as new NASA satellites and sensors have been deployed. EROS has always tried to help more people get easier access to its data, and the 2000s really demonstrated this. A pivotal event that sent Landsat demand soaring came in 2008 when the USGS opened the Landsat archive for download at no cost to users. EROS counted more than 1 million Landsat scenes downloaded in fiscal year 2009, compared to 25,000 scenes delivered in fiscal year 2001. The Earth Explorer website is a tool that endures today for delivering data from Landsat and other sources, but it's not the only source. People can now use data right in the cloud thanks to the reprocessing of the entire Landsat archive. EROS has created Landsat science products to make the data more easily usable for researchers. EROS continued its long history of interagency support in supplying imagery during disasters, including the September 11, 2001 terrorist attacks aimed at New York City and Washington, D.C. Landsat 7 captured smoke still rising above ground zero of the World Trade Center the following day, and in the aftermath, a portion of EROS staff provided far more imagery access in support of various agency requests, including satellite, aerial, and LiDAR imagery. EROS, as host of the Hazard Data Distribution System, saw more than 517,000 files downloaded in the 2 months following the December 2004 Indian Ocean tsunami that killed at least 225,000 people. Other types of disasters that HDDS has responded to include wildfires, flooding, hurricanes, cyclones, earthquakes, volcanoes, landslides, oil spills, and even sunken ships. In 2004, EROS went all digital, no longer distributing aerial photos as photographs but as digital products. In 2005, after 32 years, the photo lab officially closed and equipment and supplies were removed. In 2009, an ambitious project began, scanning film of all aerial photography at EROS with custom-built Phoenix systems operating 24 hours a day, 5 days a week. In 2017, the EROS Calibration Center of Excellence began the aspiration of being the leading organization for ensuring high-quality data for users worldwide. Knowledge of what covers the land, how the land is being used, and how that land has changed over time is foundational for local, state, and government agencies, nonprofit organizations, private land managers, and commercial industries. EROS efforts to provide land cover insights grew beyond NLCD to programs like Landfire, hosted at EROS. Landfire provides details relevant in wildfire and prescribed burning situations about a variety of conditions such as fire fuels and disturbances. Examples of other land cover science and information efforts include ongoing mapping of wildfires for burned area emergency response teams, starting in 2001 through the Monitoring Trends in Burn Severity program enacted in 2005. The creation of regional models for the Coastal National Elevation Database showing land elevation and water depth, beginning with Mobile, Alabama in 2010. Creation of a global map of mangroves using more than 1,000 Landsat scenes in 2011. Creation of a 30-meter land cover product of all of North America in 2017 under the North American Land Change Monitoring System. Development of the Land Change Monitoring, Assessment, and Projection Program, or LCMAP, providing ready-to-use annual Landsat-based land change and the land use data on a continuous schedule that started in 2020. It is in the process of integrating with NLCD. An evapotranspiration model, now called the Operational Simplified Surface Energy Balance, developed in 2006 to help account for water use and losses in agriculture through irrigation. Online tools to more easily deliver famine early warning system network data to people in parts of Africa and other food insecure parts of the world. Improving technology has enabled the more complicated research needed for the many scientific studies at EROS, including the 2019 arrival of 2 USGS supercomputers, Denali and Tallgrass, which are available for use by USGS scientists. And in summer 2023, the Hove-and-Weep supercomputer, able to perform 660 trillion floating operations per second, joined Denali and Tallgrass. For 50 years, the people of EROS have overcome difficulties and celebrated triumphs together, always centered on providing a perspective of the Earth that helps us better understand its condition. The EROS archive has become a time travel treasure for people curious about past changes on the land and what they could reveal about the future. The archive has relied on caretakers at EROS who recognize its value and the vital need to keep it available to the public. They have made extraordinary efforts to preserve the archive amid degrading and distant data and changing technologies, and they have worked to improve the quality of the data to make it more usable. And in the long and strong history of science at USGS EROS, employees have turned that valuable land remote sensing data into useful research and tools that benefit a vulnerable world hungry for solutions. From the South Dakota countryside, the technology and science at EROS will continue to reach around the world and reveal our connection to our planet and ultimately to each other.